The National Electrical Code, specifically Section 230.71b, addresses the use of single-pole units as a disconnecting means for multi-wire circuits. It allows for the use of 2 or 3 single-pole switches or circuit breakers, which are capable of individual operation on multi-wire circuits. These single-pole devices can serve as a multi-pole disconnect, with one pole dedicated to each ungrounded conductor of the circuit. However, there is a crucial condition to ensure safety and proper function. The code mandates that these single-pole switches or breakers must be equipped with handle ties or a master handle. The purpose of these handle ties or a master handle is to enable the disconnection of all conductors of the service simultaneously. This simultaneous disconnection must be achievable with no more than 6 operations of the hand. This requirement is in place to prevent situations where only some of the conductors in a multi-wire circuit are disconnected, which could create hazardous conditions or equipment damage. Let's delve deeper into the implications and practical applications of this code section. Firstly, it's essential to understand what a multi-wire circuit is. A multi-wire branch circuit is a circuit that consists of 2 or more ungrounded conductors having a voltage between them, and a grounded conductor having equal voltage between it and each ungrounded conductor of the circuit, and that is connected to the neutral or grounded conductor of the system. Multi-wire circuits are commonly used to provide both 120 volts and 240 volts power in residential and commercial settings, or other voltage combinations in 3-phase systems. Secondly, consider the implications of using single-pole breakers instead of a multi-pole breaker. A multi-pole breaker is designed to disconnect all associated conductors simultaneously with a single switching action. This ensures that if there is an overcurrent or fault condition, all affected conductors are energized at the same time. Single-pole breakers, on the other hand, operate independently unless they are mechanically linked together. Thirdly, the handle ties or master handle are the key to meeting the code requirements when using single-pole breakers on multi-wire circuits. Handle ties are devices that physically connect the handles of adjacent single-pole breakers so that moving one handle causes the others to move as well. A master handle achieves the same result but may involve a more robust mechanical linkage. The requirement that all conductors be disconnected with no more than 6 operations of the hand is intended to cover situations where a service panel might have multiple multi-wire circuits. Even in such cases, a person should be able to quickly and easily disconnect all power to the service without having to individually switch off numerous breakers. This is particularly important in emergency situations. Now let's consider some practical examples. Imagine a residential service panel with a 240 volts multi-wire circuit feeding a range. This circuit uses 2 single-pole 120 volts breakers, one for each ungrounded conductor. To comply with 230.71b, these 2 breakers must be fitted with a handle tie. If one breaker trips due to an overcurrent, the handle tie will cause the other breaker to trip as well, disconnecting both legs of the 240 volt circuit. Another example could be a 3-phase 208 volts multi-wire circuit in a commercial building. This circuit utilizes 3 single-pole breakers, one for each phase. In this case, a 3-pole handle tie or a master handle is required to ensure that all 3 phases are disconnected simultaneously. It's important to note that simply placing single-pole breakers next to each other in a panel does not meet the code requirements. The breakers must be mechanically linked with a listed handle tie or controlled by a master handle specifically designed for this purpose. Installers should always refer to the manufacturer's instructions for proper installation and use of handle ties or master handles. There are also some exceptions and special considerations to keep in mind. For example, some jurisdictions may have local amendments to the NEC that further restrict or clarify the use of single-pole breakers on multi-wire circuits. It is crucial to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Furthermore, it's important to select the correct type and size of breakers and handle ties for the specific application. The breakers must be properly rated for the voltage and current requirements of the circuit, and the handle ties must be compatible with the breakers being used. Improperly sized or installed components can create safety hazards and prevent the circuit from functioning as intended. In addition to the NEC requirements, good electrical practice dictates that all multi-wire circuits should be clearly labeled. This helps to prevent accidental disconnection of only one leg of the circuit, which can create dangerous voltage imbalances and damage equipment. Labeling should indicate that the circuit is a multi-wire circuit and identify all associated breakers. It is also a good idea to use different colored conductors for each ungrounded conductor in a multi-wire circuit. This can help to avoid confusion during installation and maintenance. For example, black, red, and blue wires are commonly used for three-phase circuits, while black and red wires are used for 240-volt single-phase circuits. Proper wiring techniques and color coding can significantly reduce the risk of errors and improve the overall safety of the electrical system. Finally, it is essential to remember that electrical work should only be performed by qualified and licensed electricians. Working with electricity can be dangerous, and improper installation or repair can lead to serious injury or death. If you are not a qualified electrician, always consult with a professional for any electrical work. In summary, NEC Section 230.71b allows the use of single-pole breakers on multi-wire circuits, provided that they are equipped with handle ties or a master handle to ensure simultaneous disconnection of all conductors with no more than 6 operations of the hand. This requirement is in place to protect against hazardous conditions and equipment damage. Always follow the NEC local codes and manufacturer's instructions when installing or maintaining electrical systems. Remember to label multi-wire circuits clearly and use proper wiring techniques. And most importantly, always consult with a qualified electrician for any electrical work. Let's further explore the practical implications of this code requirement and how it affects various electrical installations. Consider a scenario in a commercial kitchen where multiple appliances are powered by multi-wire circuits. These appliances, such as ovens, refrigerators, and mixers, often require both 120 volts and 240 volts power. Using multi-wire circuits is an efficient way to provide this power, but it also necessitates careful attention to the disconnecting means. According to NEC Section 230.71b, each multi-wire circuit must have a disconnecting means that can simultaneously disconnect all ungrounded conductors with no more than 6 operations of the hand. This can be achieved by using either a multi-pole breaker or single-pole breakers with handle ties or a master handle. In this commercial kitchen setting, it's crucial to ensure that the handle ties or master handle are properly installed and maintained. Over time, these devices can become loose or damaged, which could compromise their ability to disconnect all conductors simultaneously. Regular inspections and maintenance are essential to identify and correct any issues. Another important consideration is the accessibility of the disconnecting means. The NEC requires that disconnecting means be readily accessible, meaning that they must be located in a place where they can be easily reached without having to climb over obstacles or use tools. This is particularly important in emergency situations, where quick access to the disconnecting means can be critical. In addition to commercial kitchens, multi-wire circuits are also commonly used in data centers to power servers and other critical equipment. In these environments, reliability and uptime are paramount. Therefore, it's essential to use high-quality breakers and handle ties that are designed for continuous duty. It's also a good idea to implement a regular testing program to verify that the disconnecting means are functioning properly. This testing program should include simulating overcurrent conditions to ensure that the breakers trip as expected and that the handle ties or master handle cause all associated breakers to trip simultaneously. Another aspect to consider is the impact of voltage imbalances on multi-wire circuits. When the loads on a multi-wire circuit are not evenly distributed, it can create voltage imbalances that can damage equipment. This is particularly true for sensitive electronic equipment, such as computers and servers. To mitigate the risk of voltage imbalances, it's important to carefully balance the loads on each leg of the multi-wire circuit. This can be achieved by distributing the loads evenly among the ungrounded conductors and by avoiding the concentration of heavy loads on a single leg. In addition to load balancing, it's also important to monitor the voltage on each leg of the multi-wire circuit. This can be done using a voltmeter or a power quality analyzer. If significant voltage imbalances are detected, it's necessary to investigate the cause and take corrective action. This may involve redistributing the loads, replacing faulty equipment, or upgrading the electrical system. Furthermore, it's crucial to understand the difference between handle ties and circuit breaker interlocks. While both devices are used to link multiple circuit breakers together, they serve different purposes. Handle ties, as discussed earlier, are used to ensure that all ungrounded conductors of a multi-wire circuit are disconnected simultaneously. Circuit breaker interlocks, on the other hand, are used to prevent multiple power sources from being connected to the same load at the same time. For example, a circuit breaker interlock might be used to prevent a generator and the utility power from being connected to a building's electrical system simultaneously. This prevents backfeeding, which can be dangerous for utility workers and can damage equipment. It's important to choose the correct type of device for the specific application. Using a handle tie in place of a circuit breaker interlock, or vice versa, can create safety hazards and prevent the electrical system from functioning as intended. Moreover, it's worth noting that the NEC also addresses the use of arc fault circuit interrupters, or RFCIs, on multi-wire circuits. RFCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. The NEC requires RFCIs to be installed on certain types of circuits, including branch circuits that supply dwelling units. When using RFCIs on multi-wire circuits, it's important to ensure that the RFCI is properly rated for the voltage and current requirements of the circuit. It's also important to follow the manufacturer's instructions for installation and testing. Improperly installed or tested RFCIs may not function properly, which could compromise their ability to protect against arc faults. In addition to RFCIs, ground fault circuit interrupters, or GFCIs, are also commonly used on multi-wire circuits. GFCIs are designed to protect against ground faults, which are electrical conditions that can cause electric shock. The NEC requires GFCIs to be installed on certain types of circuits, including those that supply bathrooms, kitchens, and outdoor areas. When using GFCIs on multi-wire circuits, it's important to ensure that the GFCI is properly rated for the voltage and current requirements of the circuit. It's also important to follow the manufacturer's instructions for installation and testing. Improperly installed or tested GFCIs may not function properly, which could compromise their ability to protect against electric shock. In conclusion, NEC Section 230.71b provides specific guidelines for the use of single-pole breakers on multi-wire circuits. Adhering to these guidelines, including the use of handle ties or master handles, is crucial for ensuring the safety and proper functioning of electrical systems. Regular inspections, maintenance, and testing are essential to identify and correct any issues that may arise. And most importantly, always consult with a qualified electrician for any electrical work. Remember to consider the specific requirements of each application and to choose the correct type of devices for the job. By following these best practices, you can help to ensure the safety and reliability of electrical systems that utilize multi-wire circuits.